Suppose we sell life insurance policies. We will look at a $100,000 one-year term policy. The random variable of interest in this case is X, the payout of the policy. The payout is $100,000 if death occurs in the next year and $0 otherwise. When selling life insurance, a company figures out the probability of payout based on life expectancy. This is typically estimated based on a medical examination and/or a medical questionnaire. Suppose the policy has the following probability distribution. Find the mean and the standard deviation of X, and then tell what does the mean tell us in this example. All right, now let's notice that this is a discrete probability distribution. These values right here are normal counting values. They're not decimals. So this is a discrete probability problem. So let's do the exact same thing that we did with our die earlier. Let's find the mean and the standard deviation using a table. Now I've moved it over, and here's a table. Let's start with the mean. So our mean, I need to make a column for x, p of x. And recall that we multiply x times p of x. So 0 times 0.995 is 0. And then 100,000 times 0.005 ends up being 500. All right, now recall our formula for the mean is the sum of the x px's. All right, so let's add these up. If we add them up, that is 500. Our mean is 500. So the average payout is 500, which means the policy for the insurance company needs to be more than $500 for a person. All right, now let's go to the standard deviation. Now the standard deviation won't have as much of an impact on a real world situation when we're dealing with this insurance right now, or at least not an impact as far as you're concerned, but we're going to practice getting it anyway. We need to get the x squared, and then we need to get the x squared times the p of x. And from there, we'll do our standard deviation formula. Oops, let me x squared p of x. All right, now, so first let's get our x squareds. If we go back here and square the x, 0 times 0 is 0. If we square 100,000, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, now let's be careful. We want this times this. So 0 times 0.995 is still 0. But this number times 0.005. So I have 1 with 10 zeros times 0.005 gives me 1, 2, 3, 4, 5, 6, 7. 50 million, I believe, is the right number of zeros there. There we go. All right, now we add that up, add this column, and then let's remember our formula. Our formula for variance was the sum of the x squared px's minus the mean squared. And then, of course, we'll still have to take the square root to get down to the standard deviation. So let's fill in the sum of the x squared px's was 50 million minus 500 squared. And that gives us 49 million $750,000. And now we take the square root of that, and that gives us a standard deviation of $7,053.37. Now, in this particular situation, the standard deviation won't mean a whole lot to us, but this mean tells us that if they're paying out on average $500 for each individual buying a policy, they need to charge at least that much for their policies.